In this section of notes, we're going to look a little bit more detailed into the idea of a confidence interval and how we should be organizing our work. So if you are ever asked to construct a confidence interval, you don't want to just do the calculations. You also want to have some support there. So you're going to follow a 4-step process. The first step is state, and in the state step, you're going to list the parameter and the confidence level. In the previous video, we looked at drawing red beads from a jar. So your parameter of interest would be P equals the true proportion of red beads in the jar. And at that point, we did a 95% confidence level. So you would just say that the confidence level was 95%. For the plan step, you're going to name the significance test, or in this case, the confidence interval or the procedure that we're doing. And you're also going to check your conditions. So we already checked the conditions in that bead problem in a previous problem, but that is where you say that there's a random sample or random assignment. You check the 10% condition if you are drawing without replacement, and you check the large count conditions so that you can make sure that your sampling distribution will be approximately normally distributed. In terms of the name of the procedure, at this point we only know how to do one procedure. It's the one sample Z interval for P would be the name of our procedure. The do step is what we did in the last section of notes. That's where we start with our formula in words, with our statistic plus or minus the critical value times the standard deviation of the statistic, and then we plug in the specific formula, so P hat plus or minus C star times the square root of P times the quantity 1 minus P divided by N, and then you plug in the numbers and you get your answer. Now you also learned how to use your calculator. So for the do step, it would also be acceptable to write one prop Z int and then also your calculator input with the names. So you're saying this was my number of successes, my number of trials, my confidence level. That would be interchangeable for using the formula in the do step. And then your conclude step is that fill in the blank sentence. We're blank % confident that the interval from blank to blank captures the true blank of blank. So that same sentence we used in the last couple section of notes, you'll use again here. So another type of question that I could give you would be, if I want to have some given margin of error, how do I know what sample size I would need to be able to get a sample with that type of margin of error? So if you look at your formula sheet here, if we want to try to solve for n, that means we would need to know something for all the other values to plug in. So your P hat, you're either going to use a sample statistic or a known parameter, whatever it is that you have, you could use that. But if you don't have any idea what the P is or what the P hat is, then you're going to use 0.5. That's only if you have no information given to you about what the actual P value might be. Now, looking at this setup, this is kind of the equation that we'll use. And again, we're going to replace the P hat with 0.5s, and we're going to know what we want to put in for margin of error. And then your Z score, remember that's going to come from whatever confidence level you want, and then that will allow you to solve for N. So in this example, we have the president of a company who wants to be able to estimate how many of their customers are satisfied. And they want to be able to get an estimate that's good enough that it can be within 3%, and they want to use a 95% confidence level. So we're going to set up with using our formula. And in order to get our Z star, you can either use your 68, 95, 99.7 rule, since this is a 95. You can use inverse normal in your calculator. You can use table A. No matter what method you use, you get your Z score of 1.96. Since they didn't give us any idea of what the actual P value might be, we're going to estimate P hat to be 0.5. And our margin of error is going to be 0.03 because we were told we wanted to be within 3%. So we're going to set this up, plug everything into our formula, including plugging in the 0.5s for p, since I don't know what that is. And I'm essentially just going to solve for n. Now, once you have your n value, no matter what, you will always round up. So even though the 0.1 would typically make this round down, we're always going to round up, because if you round down, that gives you a little bit more error than what we had decided that we wanted. Don't forget to try the practice problems before moving on.